Question 10, probability. We need to find the probability that the 10th donor is the third one with O negative blood. So that means that within the first 9 people, 2 of them must have had O negative blood for the third to be the 10th. So what we're going to do is we're going to say, okay, the first 9 people, 2 of them, so this is where this bit is, 2 of them have that special blood, so 8% twice, whereas 7 of them don't. So that's 92%. So 100 take 8. So this 92% is everyone without the O negative blood. There's 7 of those in the first 9. Now this can be in any order. You can go 92, 92, 92, 92, 92, and then 8 and 8 at the end. Or you can do 8 and 8 at the start, or you can put the 8s in the middle somewhere. And because it can be in any order, you go 9, choose 2 at the beginning. And then don't forget there's 10 people, so you're going to multiply that by 8%. That's the 10th person. That's your answer. Right, down here, 5 donors give blood. What's the probability that at least one of the 5 donates O negative blood? Okay, so at least one means 1 is fine, or 2 is even better. So that 2 is at least 1. It basically means 1 or more. So 3, 4, or 5. Now, I don't want to have to do all these calculations because every single one of these calculations is going to look something like this. And I don't want to have to do that 5 times and then add the answers together. So what I'm going to do is the opposite of that. So instead of finding 1, 2, 3, 4, 5, just find the opposite. Just find, well, what happens if nobody gives that special blood? What's that probability? And then we can take the answer of that from 1, because that's all this then. Okay, so we're going to find probability that no one has the special blood. So 92%, power of 5. So 92%, 92%, 92, 92, 92, 5 times. Multiply them together. That's that. You get this. So you've got a 65% chance, or 66 I suppose, 66% chance that nobody shows up with the O negative blood, which means if you subtract it, you've got a 34% chance that someone does have the blood. And that's all of this. That's the 1, 2, 3, 4 and 5 left over. Okay. This one, a couple of different ways of doing this. I think I've probably done it the more complicated way, so bear with me. Find the minimum number of blood donors required so that the probability that at least one of them is O negative is greater than 0.97. So this is part 3 of that question. So what we're trying to do is redo question 2, but instead of getting our answer of 34%, we want the answer to be 97%. Okay, so what we're looking to do is take this thing here and put a number there so that this comes out bigger as 97 instead of 34. How you can do it is you can actually just do trial and error. You can put 7 there and then do 1 minus that, or you can put 20 there and do 1 minus that, until you get enough people so that this is 97% or more. Okay, so you could do it trial and error. If you don't want to do that, you can set up an equation and you can say, right, 1 minus, this is my 92%, and this is how many people I need for that to happen. The 1 minus was explained in the last question, and we need that to be 0.97. So this is algebra now. I'm going to subtract the 1, which gives minus 0.03. Now this is minus, and this is minus, so I'm going to cancel the minuses out. So positive here and positive here. Okay. If you didn't like that, you can move 2 things. You can move this over there and then this over there. Either way, you'll get this, but the other way around. So positives only. Now x is the power. What do we do when x is the power? We do log on both sides. So I'm going to put a log there, and I'm going to put a log here. And by doing that, it means that this power can now come to the front of the log. It's the third log rule. Okay. So when you've got the log, you can move the x to the front. Then it's x times this thing. I'm now going to divide. Opposite of multiply, divide. And this thing can just go in the calculator and I get 42.054. So to guarantee myself 97% chance, I need 42 and a bit people to walk through the door. Now, you can't have 42 and a bit So you've got to say, right, is it really 42 or 43? Now this might look like it rounds to 42, but 42 wouldn't be enough people because you need 42 and a bit. So you actually need 43 people to turn up to get a greater than 97% chance. The answer is 43. Right, we'll finish question 7 in this video, I think. So, did I say question 7? Question 10 in this video. Right, so a homeowner has a problem. You've got percentages, so probabilities, and you've got money. So when that happens, you're multiplying those two things together to work out an expected value. So, 80% times 70, that's if the repair works. So you just do 80%, 70, repair's good. This is if the repair doesn't work, and the difficulty is where this 20% comes from. So if it's got an 80% chance of fixing it, what's the chance that it doesn't fix it? That's where the 20% comes from. And how much is that going to cost you? €230, these two added up. No, sorry, this and 80 added up. Yeah, these two added up. Now, you can actually put 300 here if you assume that you pay the 70 as well. So you pay the 70, it doesn't work, you got the 150 and the 70 and the 80. I don't think you should have to pay the 70 if it doesn't work, but you can. Okay, so this could be 230 or 300, depending on whether you think that this 70 is paid, and that was in the official mark scheme as well. So my answer is 102. You might have a slightly bigger answer if you use the 300 there in that case. And then very last bit of the paper. Similar sort of question to before. It's money and probabilities. Let's just come down a little bit here. Right, so we work out how much payouts are going to cost the company. So it's 120,000 if they die, and the probability of death is 0.001. So multiply those together, that's a cost. Do the same for the disability, and then you find that the cost per person, cost per customer is 92 euros. So basically every customer that the insurance company has is going to cost them 92 euros, and they need to make a profit on that. So they're going to have to charge them more than 92 to make the profit. Now, there's 18,000 customers, so what's the cost to the company? It's 18,000 lots of 92, so 1.6 million. So that's how much the company is going to have to pay out for deaths and disability. But now, they want to make a profit on that of 900,000, so we're going to add the 900,000 on. So now we've got 2.5 million. And then we're going to say, okay, so how much does each person have to give us if we want to bring in 2.5 million? You divide it by 18,000, you get 142, and that's the charge per customer per year.